Welcome to my channel, STEM Cafe, where we make everything science, technology, engineering, and mathematics very easy to comprehend, fun, easy to assimilate, recall, and in short, obsessive. We make it fun as game here. And today, we are treating some questions under linear, simultaneous, quadratic, and polynomial equations. We have treated enough questions in the lectures on linear, simultaneous equations, even some quadratic. But we are trying to deal more about the roots, about the manipulation of roots. This time around, we have treated some in the notes, and I'd like us to summarize, I'd like to give you a summary about what we have treated before. For polynomial equations, I said for quadratic, it's always of this form. And because the degree is 2, they always have 2 roots. We have treated how to get the roots, but the relationship between the roots, sum and products, that's what we are talking about here now. So, if the roots are alpha and beta, what happens is, we know that alpha and beta will be equal to minus b over a, and alpha beta will be equal to c over a. That's what you observe. And we also observe that for all the polynomials, all of them, squares. Okay, I got that. Now, we note that for the squares, we know that for the summation, we always represent the summation of all the polynomials, the summation of the roots as this. The summation of the roots as this. And we also refer to this as S2. The summation of the squares of the roots as this. We refer that one to S2. When we are talking about pairs of the roots, we refer to that as this, alpha beta. And for this quadratic, because it's just 2, we can say this as c over a here. Please take note of this. Now let's go to cubic. Cubic is in 3. The degree is 3. So we have ax plus bx squared plus cx plus d equals 0. So the roots, alpha, beta, gamma. And the sum of the roots, just as I said, we denote it like this. We can also take it as this. From the lecture, you get all this. Then, this sum will be minus b over a. Minus b over a. Look at this, sum of pairs, as in products. Sum of pairs will be c over a. Can you see now? In this instance, the c is the constant, but the c in this instance is the coefficient of x. Can you see? Now, when it is in 3s, you refer to that as minus b over a. You can see positive, negative. That's how it is. So, you can see. So, we said this one. You can also see alpha squared is S2. And summation 1 over alpha is S minus 1. Same thing applies there. Summation 1 over alpha is S minus 1. Please, this S is about sum of alpha, not the pairs, not anything. It only applies to. And this one, in all instances, is alpha plus beta plus gamma. For this cubic. If it is for this one, it is alpha plus beta. This way. Alpha plus beta. That is for quadratic. Please take notes. And you can also say this as S1. So please take note of that. Now let's talk about the quadratic. So, for quadratic, it's like this. Ax raised to power 4 plus bx cubed plus cx squared plus dx plus e equals 0. So you can see, if you look at the pattern, it is always positive, negative, positive, negative, positive. You get what I'm saying now. If the roots are alpha, beta, gamma, delta. Therefore, summation alpha, we use it to denote alpha plus beta plus gamma plus delta. That is minus b over a. And we can represent this one as S1. Take note of that. For summation alpha beta, that is sum of the roots in pairs. It applies to that, to the what's it called, quadratic and cubic too. It will be c over a for the sum of the roots in threes, that is summation alpha beta. What this one means now is alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. So that's what it means, and we refer to this as minus d over a. You can see. So for all of the products, that is e over a. So you can see what I'm saying. Positive, when you are putting it here, negative, positive, negative, positive. You can see. Now, since you have gotten this, to make it easier, I want you to also note something. Please, this one will enhance the ease by which you can handle almost any question that comes under the roots of polynomials. We said S1 is summation alpha, and which is minus b over a. That's S1. Now, S2 is summation alpha squared. So depending, if it is 3 roots, it will be alpha squared plus beta squared plus gamma squared. If it is 2 roots, it will be alpha squared plus beta squared. Please take note of that. And from our observation, it was discovered that this will be summation alpha all squared minus 2 summation alpha beta. And most times, summation alpha is minus b over a. And this one is c over a, that is summation alpha beta. Most times, all the time is c over a. Let me do that. Summation alpha minus b over a. In all cases, and alpha beta is c over a. Another one I want you to see is s minus 1, which is equal to summation 1 over alpha. That is, if it is like quadratic, that is 1 over alpha plus 1 over beta. If it is cubic, that is 1 over alpha plus 1 over beta plus 1 over gamma. If it is quartic, that will be 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. Please take note. And this will be depending on the degree. Let's say for quadratic, it will be summation alpha over summation alpha beta for quadratic. For cubic, it will be summation alpha beta over summation alpha beta gamma. You can see just 1, 1. The numerator is lower by one of the roots to the denominator. And then quartic, it will be summation alpha beta gamma over summation alpha beta gamma delta. Please, I believe once you have you studied the notes, you get this one easily. And after this, for cube, I cannot give you a straight formula for S3. I am giving you S1, S2, S minus 1. But for S3, I won't be able to give you a standard formula for this. It varies from one to the other. And that is why, with practice, you can easily use substitution. Practice, you can easily use substitution in this instance. Now, let's go into the real thing we have dedicated this lecture for: solution of questions. And please, if you have not subscribed, kindly subscribe, assist to share, please, and do anything you know that will encourage this. Your comments and other things you do have been the source of encouragement, and I appreciate everything you have done. Kindly share as well. Thank you very much. Anything you believe we can do for you, I'm always available. You can make comments, and then you send message to this address. You can send message to your comments or to this address. So you can, and if you make comments, I will attend to it. Anything, I assure you that. Now let's solve this. The question says, find the value of k if y minus 1 is a factor of y cubed plus 4y squared plus 10y minus 6 equals to 0. That is, if we substitute, since that is a factor, y minus 1 is a factor, and that means y minus 1 is 0. So what does that mean? That is, when we substitute y equals 1, when we substitute 1 for y in the equation, we are going to have 0. That's the factor theorem. Now let's put it. So we have 1 plus 4 plus k to 1 minus 6 equals 0. So this is 1, this is 4. 1 plus 4 plus k minus 6 equals 0. So this is 5 minus 6. That is k minus 1 equals 0. Therefore, k equals 1. Simple and straightforward. So this is example of factor theory. We have this: factorize 12y squared minus 15xy plus 18x squared. So we have something like this: 2y squared minus 15xy plus 18x squared. You know, when you multiply this, it's going to give you 36x squared y squared. And two expression in xy that will give you 15xy. When you add them, will be something like this. You have 2y squared minus 12xy minus 3xy plus 18x squared. You can see. So this will give us 2y into y minus 6x minus 3x into y minus 6x. So this will give us 2y minus 3x into y minus 6x. So this factorize completely: abx squared plus 6y minus 3ax minus 2byx. So we are going to have something like this: abx squared plus 6y minus 3ax minus 2byx. You can see this contains terms in y. So let's rearrange. We are going to have abx squared minus 3ax plus 6y minus 2byx. So we have the terms of ax here. So we have ax into bx minus 3 plus 2 into plus 2y into 3 minus 2 minus bx. 2y into 3 minus bx. Now you can see this one is minus. So to rearrange, you can say ax into bx minus 2y into bx minus 3. Depending. If I arrange this one in this other way, it will give us this. So that the ones in bracket will be the same. So I'm going to have ax minus 2y into bx minus 3. So that's the factorization of this. If x minus 1, x plus 1 are both factors of equation px squared plus qx plus 6, evaluate p and q. So we have this equation px squared plus qx plus 6. And we are told that x minus 1 is a factor. So that is, if we substitute x equals to 1 into the equation, we are going to have 0. So what does that mean? It means that p into 1 squared plus q into 1 plus 6 will give us 0. That is, p plus q plus 6 will give us 0. We also told that x plus 1 is a factor. Okay, it's factor. That is, when we substitute x equals to minus 1 into the equation, we are going to have 0. So we are going to have p into 1 minus 1 squared plus q into minus 1 plus 6 equals 0. So what does that give us? It means we are going to have p minus q plus 6 equals 0. P minus q plus 6 equals 0. So we have p plus q equals minus 6. P minus q equals minus 6. So when we add these two, it means that we are going to have 2p is equal to minus 12. So p equals minus 6. And if we insert this into this equation, it means that q equals 0. And so we have some set of expressions to handle here. Factorize completely. 1, 4x plus 3y bracket squared minus 3x minus 2y all squared bracket squared. 2, x squared plus 2xy plus y squared plus 3x plus 3y minus 18. Third one is 4abx minus 2axy minus 12b squared x plus 6b xy. And the first one is ac minus 2bc minus a squared plus 4b squared. Now let's take them one by one. The first one is this. All these ones are simple. They are multiple choice questions in an exam. So we have this plus 3y all squared minus 3x minus 2y all squared. Please, you can see the difference of two squares. So you don't have any problem. Just go straight to addition and subtraction. So you have 4x plus 3y plus 3x minus 2y into 4x plus 3y minus 3x plus 2y. Straight. You know this will affect this. So we are going to have 7x plus y. And this one is 4x. So that one is x plus 5y. So that's the answer for the first one. Let's go to the second one now. So we have x squared plus 2xy plus y squared plus 3x plus 3y minus 18. If you look at this one gives us perfect square. And then we will now expand to this. So we are going to have this one to be equal to x plus y all squared. If you look at this, if you factorize, we are going to have 3 into x plus y, and then we are going to have k squared plus 3k minus 18, where k is x plus y. You can see. So this now gives us k squared plus 6k minus 3k minus 18, and that gives us k into k plus 6 minus 3 into k plus 6. Then this now gives us k minus 3 into k plus 6. Now you have to bring this back into this equation. So at the end of the day, the factorization of this expression is x plus y minus 3 into x plus y plus 6. So that is the answer. Now let's do the next one. We have the question 4a dx minus 2a xy minus 12b squared x plus 6b xy. So we have to factorize this completely. Let's look at this. We have some common this thing. We have 2ax into 2b minus y. And here too, we have 6b. We have 6b x into 2b minus y. So you have 2a x minus 6b x into 2b minus y. You can still factorize further and say 2x into a minus 3b into 2b minus y. So that's the solution to that, the third one. So the fourth one, we have AC minus 2BC minus A squared plus 4B squared. AC, A squared, 2BC, B here. So let's factorize this. This one is going to give me AC minus 2BC plus 4B squared minus A squared. So that's the rearrangement. It's the same thing. Now let's factorize. C is common to this place. So I can say C into A minus 2B. A minus 2B plus, if I should factorize this, I'm going to have 2B plus A into 2B minus A. You can see. So this one and this one. You can see this one is this one times minus 1. So I can rearrange it and say C into A minus 2B minus A minus 2B into 2B plus A. So, and that gives me, you can see that A minus 2B is common to both sides. A minus 2B into C minus 2B minus A. This one times this minus. So that is the factorization for this. Look at it. Now let's look at this equation. We have to solve for x. If x squared plus y minus 8 equals to 0, and y plus 5x minus 2 equals to 0. So what do? We have our equation like this: x squared plus y minus 8 equals 0. And now, in the second equation, you can say y equals to 2 minus 5x. Now, let's substitute 2 minus 5x for y in the first equation. Let's make this one. Let's make this 2. So, substitute 2 minus 5x for y in 1. So, I have x squared plus 2 minus 5x minus 8 equals 0. So, that gives me x squared minus 5x minus 6 equals 0. So, x therefore, you can say x squared minus 6x plus x minus 6 equals 0. So, x into x minus 6 plus 1 into x minus 6. So, x plus 1 into x minus 6 equals 0. Therefore, x equals to minus 1 for 6 are the solutions. So, we have solved for x in this. The question states, if x plus 2 and x minus 1 are factors of lx cubed plus 2kx squared plus 24, find the values of x of l and k. So what does that imply? It implies that the factors are x plus 2 and x minus 1. Therefore, minus 2 and 1 are roots. That is, we'll give that expression, we make it 0. So let's put 2, substitute 2 and minus 1 for x. Let's try. So we have L into minus 2 cubed plus 2k minus 2 squared plus 24 equals 0. So I have minus 8L plus 8k plus 24 equals 0. So let's divide through by 8. So I have k minus L plus 3 equals 0. So I can say k minus L equals minus 3. Now let's substitute minus 1. L into 1 cubed plus 2k into 1 squared plus 24 equals 0. So I have L plus 2k equals minus 24. So let's make this our first, second derived equation. Let's add 1 and 2. Add 1 and 2. So this one we cancel, L we cancel. So we are going to have 3k is equal to minus 27. Therefore, k is equal to minus 27 over 3, which equals to minus 9. That is for k. Now for L, we'll substitute this into either of the equation, either this one or this one. So let's substitute minus 9 for k in 1. So what do I have? Minus 9 minus L equals to minus 3. Therefore, L will be equal to minus 9 plus 3, which is minus 6. So if you look now, we have to factorize 1, y cubed minus 4xy plus xy cubed minus 4y. 2, 4a squared minus 12ab minus c squared plus ad squared. 3, 9b squared minus q squared plus 6qr minus 9r squared. 4, 1 minus brackets a minus b close bracket squared. So the a minus b are squared. 5 m cubed minus 2m squared minus n plus 2. Okay, that's 5. This is 6. 6x minus 5 minus x squared. 7. 9 minus open bracket x squared minus 3x minus 1 close bracket all squared. So let's take it one after the other quickly. The first one is y cubed minus 4xy plus xy cubed minus 4y. So if you look at it, for ease, we need to rearrange this. So we are going to have y cubed plus xy cubed minus 4xy minus 4y. So you can see. So we have y cubed common to this place is 1 plus x. Minus 4 is common to this place, minus 4y. Minus 4y into x plus 1. So you can see. So we can still say this will now give us y cubed minus 4y into 1 plus x. So you can say y is common to this place too. Y into y squared minus 4 into 1 plus x. You can still break this one further. So you can now say y into y plus 2, y minus 2, 1 plus x. You know why? This one, this is difference of two squares. That is y squared minus 2 squared. So this one is 4a squared minus 12ab minus c squared plus 9b squared. So for factorization of this, we might need to rearrange. So we are going to have 4a squared minus 12ab plus 9b squared minus c squared. Now we need to look for two numbers whose product is 4 times 9, that's 36, and the difference is minus 12. Or the sum is minus 12. So we are going to have this one 6 times 6, yes. So we are going to have 4a squared minus 6ab plus minus 6ab minus 6ab plus 9b squared minus c squared. So factorizing, I'm going to have this side, this is the one I'm concentrating on. So this one is going to give me 2a into 2a minus 3b minus 3b into 2a minus 3b minus c squared. So looking at this, you can see that we have 2a minus 3b all squared minus c squared. So you can see, so we have difference of two products. And we have difference of two squares. That's what we have now. So this is difference of two squares. So we are going to have 2a minus 3b plus c into 2a minus 3b minus c. So that's the answer. So the next one is 1 minus a minus b all squared. I intentionally put this one there so that all the difference and whatever will be clear. So what is this one? It's giving us 1 squared minus a minus b all squared. You can see, just like the previous one. So this is difference of two squares. So it's going to give us 1 plus a minus b into 1 minus a plus b. So very straightforward, simple. N squared minus n plus 2. We have n cubed minus 2n squared minus n plus 2. So it's going to give us n squared into n minus 2 minus 1 into n minus 2. So working further on this, it's going to give me n squared minus 1 into n minus 2. So I can break this one further again. It's going to be n plus 1 into n minus 1 into n minus 2. That is for this. Now let's go to the next one. That is 6x minus 5 minus x squared. So I'm going to find, so the product will be minus 5 and the sum will be, the product is going to be minus 5 times minus 1, that is 5, and the sum will be 6. So I'm going to have 5x plus x minus 5 minus x squared. So let me rearrange. It will give me 5x minus 5 plus 5x minus x squared. So you can see. So it's going to be x is going to be 1 into x minus 5 plus x into 5 minus x. So it's also 1 into x minus 5 minus x into x minus 5. So I have 1 minus x into x minus 5. So that's the factorization of this. Easier way, you multiply 2 by minus 1. Let's do that way. So if I multiply 2 by minus 1, I maintain the one outside. So it's going to be minus 1 into x squared minus 6x plus 5. You can see, very easy now. So I can now say it's going to be minus 1 into x squared minus 5x minus x plus 5. So I have minus 1 into x to x minus 5 minus 1 into x minus 5. So it's going to give me minus 1 into x minus 1 into x minus 5. So I either multiply this one by minus 1 or this one by minus 1, any of the two. So it's going to be 1 minus x into x minus 5 or 5 minus x into x minus 1, any of these. So that's the answer. So you can say 1 minus x. So this one is easier. So once I see something like this is what I normally do, so that I won't get confused. So we have this 9 minus x squared minus 3x minus 1 squared. So this will be equal to 3 squared minus x squared minus 3x minus 1 squared. Now this is difference of two squares. So we can do it like this: 3 plus x squared minus 3x minus 1 into 3 minus x squared plus 3x plus 1. And that will give us x squared minus 3x plus 2. And this will give us 4 plus 3x minus x squared. Now let's factorize each quadratic equation. So this one is going to give us x squared minus 2x minus x plus 2. This will give us 4 plus 4x minus x squared. So this is going to give us x into x minus 2 minus 1 into x minus 2. And this one is going to give us 4 into 1 plus x, 1 plus x minus x into 1 plus x. So at the end of the day, we are going to have x minus 1 into x minus 2 into 4 minus x into 1 plus x. So the factorization of 9 minus bracket x squared minus 3x minus 1 bracket all squared is equal to x minus 1 into x minus 2 into 4 minus x into 1 plus x. Now let's quickly solve the ones. First one says if half into bracket 3y minus 4x all squared is equal to 8x plus kxy plus ly squared. Find k and l. The second one says solve x squared plus n squared equals 29 and m plus n equals 7. That is, we should find m and n. Third one is x minus 1, x plus 1, and x minus 2 are factors of ax cubed plus bx squared plus cx minus 1. Find a, b, and c. The fourth one says find the remainder when x cubed minus 2x squared plus 3x minus 3 is divided by x squared minus 1. And the last one says divide 2x cubed plus 11x squared plus 17x plus 6 by 2x plus 1. Now let's take it one after the other, one by in turns. The first one is half 3y minus 4x all squared is equal to 8x plus kxy plus ly squared. Let's multiply 2 by 2 first. Multiply 2 by 2. So that this half will be cancelled. We are going to have 3y minus 4x all squared is 16x plus 2kxy plus 2ly squared. Now let's expand this one. We are going to have 9y squared minus 2 into 3y into 4x plus 16x squared. Expansion of square. When we expand square of linear expression, that's how we get it. That is, the square of a minus 2ab plus b squared is going to give us 16x. So this one should be 16x squared. This one should be x squared, sorry. So it's 16x squared plus 2kxy plus 2ly squared. Now let us equate the coefficients. Equating coefficients. You can see for y squared, 9, that is coefficient here, is equal to 2l, is equal to 2l. Therefore, l is equal to 9 over 2 or 4.5. Now, equating coefficient of k of xy. Equating coefficients of xy. This one and this one. So we have minus 2 into 3 times 4xy is equal to 2kxy. So you can see, which means that k is equal to minus 3 times 4 times 2 over 2. Minus 12. So our k is minus 12 and our L is 4.5. Now we have this. This n squared plus n squared equals 29. That's the first one. N plus n equals 7. So there are several ways you can look at it. You can make one the subject of the formula, put it here, and you can catch one with it. For me, I can just say, let me square this one. What does it give me? It gives me n squared plus n squared plus 2nn equals 49. And you know this one is 29. Therefore, 29 plus 2nn equals 49. 2nn is equal to 49 minus 29, which is 20. It's not every time you can do this. Just observation, catching form. That's all. With this technique, you can do it without even writing anything. So, and you know that n plus n squared plus n squared plus 2mn equals n plus n squared. And n minus n squared is equal to n squared plus n squared minus 2nn. So what does that give us? N minus n all squared is equal to 29 minus, you can see 2mn is 20, which is 9. So n minus n is equal to 3. You can say plus or minus 3. And we have n plus n is equal to 7. So let's take plus 3 first. When we add the 2, 2m is equal to 10. N is equal to 5. And if n is equal to 5, n will be equal to 2. That is if you substitute it here. Now let's see if n minus n will be the negative. So now I am choosing minus 3. So n, when I add these two equations, I'm going to have 2n is equal to 4. Therefore, n will be equal to 2. So in this instance, I have all n equals to 2. So if n equals to 2, I put it back into this equation, or in this place. If this one is 2, 2 here, 2 minus n equals to minus 3. Therefore, n will be equal to 2 plus 3, which is equal to 5, or 5. So you can see. So you can do it like this, or you can outright say, make n the subject of the formula here, which is 7 minus n. And then you put this one back here, and that's going to be 7 minus n all squared plus n is equal to 29. And then on expansion, what would that be? 49 plus n squared minus 14n plus n squared is equal to 29. So what does that give me? Give me 2n squared minus 14n plus 20 equals 0. So n squared minus 7n plus 10 equals 0. So from here, I can easily get what my n will be. N squared minus 5n minus 2n plus 10 equals 0. So on factorizing this, n into n minus 5 minus 2 into n minus 5 equals 0. So what does that give me? N minus 2 or n minus 5. So n equals to 2 or 5. So I get it straight. So with what you have been doing all this while, and you know, I believe you find it very easy. There are several ways. Just observation will direct you. When you observe very well, you will know how to tackle any of the questions that comes your way. Now we have the next one is this. X minus 1, x plus 1, x minus 2 are factors of ax cubed plus bx squared plus cx minus 1. Now we have to find a, b, and c. Now, if this one is factor of this, it means that these ones will make this expression to be equal to, let me write it like this. We make this expression to be 0. That is ax cubed plus bx squared plus cx minus 1 will be 0. If these ones are there. And from our knowledge of roots, you can easily work this out. What is the sum of these roots? 1 minus 1 plus 2 will be equal to minus b over a. That's minus b over a. For the product, that is the product of the roots, 1 times minus 1 times 2, and that is equal to minus 1 over a. You can see now, straightforward. So this one is minus 2 is equal to 1 over a. 1 over a. So from here, I can find what a is. So a is equal to minus half. A is equal to minus half. So here again, I have this one to be 2. So which means that minus b is equal to 2 times a. This is 2 times minus half minus 1. So b is equal to 1. So our b is equal to 1. So we have found a, we have found b, and now we can find c. That is the sum in pairs, that is summation alpha beta, which is equal to 1 times minus 1 plus 1 times 2 plus minus 1 times 2, which is equal to c over a. This one is here, minus 1 over a. So that one is c over a. So this is minus 1 plus 2 minus 2 will be equal to c over a. And you know what our a is from here? Our a is, so this one is minus 1 is equal to c over a. So c equals to minus 1 times a, which is minus 1 times minus half, which is half. So our c is half. So a is minus half, b is 1, c is half. Now we can also use factor theorem. So if I use factor theorem, it means ax cubed plus bx squared plus cx minus 1 will be 0 for each of these values. Now let me impute each into this. So roots are 1, minus 1, and 2. That is not to make this one 0. Now let me put 1 here. I have a plus b plus c minus 1 equals 0. Therefore, let me write in the expression here. A plus b plus c equals 1. That's the first one. The next one, if I impute minus 1, this one will be minus. I have minus a plus b minus c minus 1 equals 0. So let me multiply 2 by minus 1. So this one a minus b plus c plus 1 equals 0. Therefore, I'm going to have a minus b plus c is equal to minus 1. You can see a plus b. So a minus b plus c. At the end of the day gives me minus 1. Now let me use the next one. This is 2. So I'm going to have 8a plus 4b plus 2c minus 1 equals 0. So I can now say 8a plus 4b plus 2c is equal to 1. Now, so I call this 1, I call this 2, I call this 3. So if I should subtract this one from this one, if I subtract 2 from 1, that is 1 minus 2. This one and this one will cancel out. This one and this one will cancel out. I'm going to have 2b will be equal to 2. So therefore, b is equal to 2 over 2, which is equal to 1. I have gotten 1 there. Next one now. Let me slot in this value here. So I'm going to have a plus 1 plus c is equal to 1. A minus 1 plus c is equal to minus 1. So what does this give me? It means that a plus c will be equal to 0. And in the same instance here, that's what it gives me. A plus c is equal to 0. Now, in this place too, let me slot in the value of b into this place. That is 1. So I'm going to have 8a plus 4 plus 2c is equal to 1. Now, at the end of the day, I'm going to have 8a plus 2c is equal to minus 3. And you can see from here, we can see that a is equal to minus c. This one. Oh, okay, let me multiply this one by 8. 8a plus 8c is equal to 0. That's what it gives me. 8a plus 8c is equal to 0. Therefore, let me subtract this one from this place. So I have 6c here. This one, let me call this one 4, and this one 5. So 5 minus 4. So this one minus this one 0. This one minus 6c and 3. So you can see 6c is equal to 3. Therefore, let me continue here. Therefore, c is equal to 3 over 6, which is equal to half. And from here, we can now put in this value into this place. So a plus half is equal to 0. Therefore, a is equal to minus half. So, if we look at the 3 now, I have a equals minus half, b is equal to 1, and c is equal to half. I believe this is the same thing as when we try to use the knowledge about root of polynomials. Now for this one, we are told to find the remainder. when x cubed minus 2x squared plus 3x minus 2 is divided by x squared minus 1. So we have x cubed minus 2x squared plus 3x minus 3 is divided by x squared minus 1. Looking at this, okay, let me do straight. X multiplied by x squared multiplied by x will give us this. So we put x here. So we have x cubed minus this one times this one is x. So I have minus x. Now subtracting, I have this one cancelled. So this one becomes 4x. And this one is minus 2x squared plus 4x minus 3 for ease. Let me write everything down. Now looking at this again, I have minus 2. So minus 2 multiplied by this one, minus 2x squared. This one is plus 2. Okay, plus 2. Sorry, this will be here. Plus 2. So this one cancels this. I'm going to have 4x. This one minus this. This one minus this, minus 5. So the remainder is 4x minus 5. Now that will divide 2x cubed plus 11x squared plus 17x plus 6 by 2x plus 1. So what do we have here? 2x in 2x cubed is x squared. So let's multiply 2 by x squared. So we have 2x cubed plus x squared. So subtracting, this one will cancel, and this one will be 10x squared. Now 2x here is equal to 5x. 5x. So 5x times this one is going to give 10x squared plus 5x. So subtracting, this one gives me 12x. This one gives me 12x. 2x here is 6. So 6 times 2x is 12x. Times 1, 6. So that's the answer. X squared plus 5x plus 6. So that's why the polynomial px is divided by x minus 1, the remainder is 5. And when divided by x minus 2, the remainder is 7. Find the remainder when px is divided by x minus 1, x minus 2. Now, we have px. And when divided by x minus 1, it will give us another function. Let's say fx. And will remain 5. The remainder will be 5. You know, it's a linear, it is divided by linear function. The divisor is linear function, the quotient is fx. So the remainder is 5. When it is divided again by x minus 2, let's say we have the quotient as gx, remainder 7. Now, because of what we have now, there is a way we can represent px again. Let's now say px is divided by x minus 1, x minus 2. It will give us something like kx remainder. You see, we are going to have a quadratic equation that is of degree 2. So we are going to have remainder maximum in linear function, and let us represent it as ax plus b. So you can see now, since we have known this, we can work with this now. Let's say px, let's represent it will be kx into x minus 1. Oh, this one will be x minus 2, please, into x minus 2 plus ax plus b. You know, this will not multiply this one because this is remainder. Take notes. Now, this one is equal to this one is equal to this one, which means that if we, using remainder theorem, if we substitute x minus 2 into this expression, it's going to give us the remainder is 7. If we substitute 1 for x in this expression, the remainder will be 5. Let me show you what I mean. Now, px, using remainder theorem, when x is equal to 1, px will be equal to 5. And when x equals to px will be equal to 7. Now, in this expression, if I should put 1 here, everything here will be 0. You understand? Therefore, 5 is equal to a plus b. 8x, you know, x is 1, so plus b. For the second one, when x equals to 2, 7 is equal to 2a plus b. Now let's find our a and b. Let's subtract this one from this place. So we have 2 equals to a. Our a equals to 2. You can see. Now, what's our b? B will be equal to 5 minus 2. This is equal to 3. Therefore, remainder, when divided by x minus 1, x minus 2 will be equal to 2x plus 3. So the answer is 2x plus 3. When a polynomial px is divided by x minus 2, the remainder is 7. When px is divided by x minus 3, the remainder is 9. If rx is the remainder, when px is divided by x minus 2, x minus 3, then the value r minus 1 is now. Let's do it like this. When px is divided by x minus 2, we have fx remainder 7. When px is divided by x minus 3, we have gx remainder 9. Now, when px is divided by x minus 2, x minus 3, we have rx, then we have hx remainder rx. From the question, that will be rs. And because this one is divided by linear equation, by quadratic equation, this one will be expressed as linear equation. So let me express it. So we have px is equal over x minus 2 into x minus 3 is equal to hx remainder ax plus b. So rx will be equal to ax plus b. Now let's find our rx. Px can be expressed again as 8x into x minus 2, x minus 3 plus ax plus b. Plus ax plus b. And from the question, when we substitute 2 here using remainder theorem, the answer will be equal to 7, and everything here will be 0. That is remainder theorem. So when x equals to 2, px is equal to 7 and is equal to 2a plus b. When x equals 3, px, that is the remainder, is equal to 9, and that will be 3a plus b. So subtracting 1 from 2, we have 2 equals to a. And how do we find b? 4 plus 3. So b is equal to 3. So rx is equal to 2x plus 3. We are now asked to find r minus 1. So r minus 1 will be equal to 2 into minus 1 plus 3, which is equal to 1. So r minus 1 is 1. The polynomial px equals x raised to the power 4 minus 2x cubed plus 3x squared minus ax plus 3a minus 7. When divided by x plus 1, leave the remainder 19. Find the value of a. Also find the remainder when px is divided by x plus 2. Now this is what happens. We know the remainder theorem. And the equation is this: 2x cubed plus 3x squared minus ax plus 3a minus 7. So when divided by x plus 1, which means that when we substitute minus 1 into this equation, it's going to give us 19 by remainder theorem. So 19 will be equal to 1 raised to the power minus 1 raised to the power 4 minus 2 into minus 1 cubed plus 3 into minus 1 squared minus a into minus 1 plus 3a minus 7. So 19 will be equal to 1. This minus plus 2 plus 3 plus a plus 3a minus 7. So we have 19 equals 3, 6 minus 1. So it's going to be 4a minus 1. 20 equals to 4a. Therefore, a equals to 5. So the expression will now be x raised to the power 4 minus 2x cubed plus 3x squared minus 5x plus 15 minus 7. That is 8. Plus 15 minus 7, that is 8. So you are now told what will be the remainder when it is divided by x plus 2. That is, we impute minus 2 into this equation by remainder theorem. If divided by x minus 2, x plus 2, sorry, p minus 2 is the answer, is the remainder. So you have p minus 2 is equal to minus 2 raised to the power 4 minus 2 into minus 2 raised to the power 3 plus 3 into minus 2 squared minus 5 into minus 2 plus 8. So we are going to have 2 raised to the power 4, 16, minus 2 times this, that's 16 again, 4, that's 12, this is 10, plus 8. So we have this as 32, 44, 54, 62. So p minus 2 is 62. The polynomials 2x cubed plus x squared minus ax plus 2 and 2x cubed minus 3x squared minus 3x plus a, when divided by x minus 2, leave the same remainder. Find the value of a. So the first polynomial, let's call that one fx, is equal to 2x cubed plus x squared minus ax plus 2. And the second one, let's call it gx, is equal to 2x cubed minus 3x squared minus 3x plus a. And we are told that when divided by x minus 2, remainder are the same. Therefore, by remainder theorem, f2 is equal to g2. So let's now substitute 2 into the equations. So we have 2 into 2 cubed plus 2 squared minus 2a plus 2 is equal to 2 into 2 cubed minus 3 into 2 squared minus 3 into 2 plus 8. So this is 16 plus 4, 20 plus 2, that's 22, minus 2a. So we have 16 minus 12, that is 4, minus 6, that is minus 2, minus 2 plus a. So let me add 2 to this place and plus 2 to this place. So we have 24 equals 3a. Therefore, a equals to 8. So the value of a is 8. When a polynomial px is divided by x, x minus 2 and x minus 3, the remainders are 1, 3 and 2 respectively. If the same polynomial is divided by x times x minus 2 times x minus 3, the remainder is gx. Then the value of g1 is, so we have to first start. We have px over x is equal to, let's say, fx remainder 1. Px over x minus 2 is equal to hx remainder 3. Px divided by x minus 3 is equal to kx remainder 2. And then we also know that px divided by x into x minus 2 into x minus 3 will be equal to lx remainder gx. And from our knowledge, we know that gx will be a quadratic equation because this one will be cubic equation. The degree of this one will be 1 less than the degree of the divisor here. So we can now say px is equal to lx into x minus 2 into x minus 3 plus gx. And as I explained, gx will be a quadratic equation. So gx will be ax squared plus bx plus c. Therefore, we can now express px adequately as lx into x minus 2 into x minus 3 plus ax plus b plus c. Then, using remainder theorem, we know that p0 is equal to 1, which will be, if I put 0 here, everything here will be 0 for x, and then I'm going to have a0, sorry, this one is squared, a0 squared plus b0 plus c is equal to 1. Therefore, c equals to 1. This one will be ax squared plus bx plus c, please. Then I have gotten c. Now for when it is 2, p2, because using remainder theorem, so it's going to be 3, and I'm going to have everything here be 0. So this one will be 4a plus 2b. So 3 equals to 4a plus 2b plus 1. When it is 3, is 2. And that will be 9a, because here will be 0. 9a plus 3b plus 1. Therefore, 4a plus 2b is equal to 2. 9a plus 3b is equal to 1. Now, for ease, let me multiply this one by 3, this one by 2. So I have 12a plus 2b plus 6b is equal to 6. 18a plus 6b is equal to 2. Now, subtracting this one from this piece, I have 6a is equal to minus 4. So a equals to minus 4 over 6, which is minus 2 over 3. Now, to find b, let me bring this one back into this space. I have 12 into minus 2 over 3 plus 6b is equal to 6. So, this is minus 8 plus 6b is equal to 6. 6b will be equal to 14. So, b equals to 14 over 6, which is 7 over 3. 14 over 6, which is 7 over 3. Therefore, gx is equal to minus 2 over 3 x squared plus 7 over 3x plus 1. The final part says, what is the value of g1? So g1 will be equal to minus 2 over 3 plus 7 over 3 plus 1, which is minus 2 plus 7 plus 3 over 3. And that is 8 over 3. So g1 is 8 over 3.